Burcin Kaplanoglu, head of Oracle Industry Lab and LinkedIn's top voice of 2023, is a renowned executive, technologist, and thought leader. As co-founder of Oracle Industry Lab, he drives innovation in AI, productivity, and sustainability. In his keynote address, Dr. Kaplanoglu will discuss the future of construction, AI, and robotics, showcasing the latest innovations and trials for engineering and construction. Please welcome Burcin Kaplanoglu.
Good morning. And it's awesome to be at a conference that safety comes first, by the way. I don't know how many of you, but one of the things I've been doing for years is when I check into a hotel, I actually look at that thing at the back, it's described. I sometimes even actually walk to the exit. And this is probably part of the industry training, like we all got used to, these practices. Now, today I'm going to talk about AI for construction engineering. And when I talk about it, look, there's a lot of hype out there, right? So I'm going to talk about things that are actually tangible, things that you can leave here with. We're also going to share a research we have done about data capture and how, best practices for that too. So the goal is not just to hype this room, is actually show you tangible things. Things have meaning that you can actually walk away. What is Oracle Industry Lab? So I'm going to spend 10 minutes to kind of give you an overview what it is. We started this lab, which is a physical testing ground for technologies, in 2018. Back in 2017, three of us, Mike, Cecilia, and Deveron, and I, were in a conference room. We were discussing how hard it is to innovate when you run your day-to-day operations. I came from the industry, spent almost 18 years in the industry, and day-to-day operations, some stuff to implement is very complicated and difficult. I told them the story about this is now almost 12 years ago, was attempted to start a drone inspection program. Well, the concept was there. It's pretty easy. We were building cell towers. You do drone inspections. By the way, at the time, FAA regulations are pretty strict, so it's very hard to actually do these inspections, so we would hire a third party. And if you look at the key things, in terms of safety, nobody's climbing, right? It solved the issue. In terms of cost, it solved the issue too, because you're sending one person to a remote site, which is a cell tower, right? Versus you're sending three people, an observer, a climber, and a safety personnel. So the cost is significantly lower. In terms of practice itself, the data collection, the quality is much better. Why shouldn't we do this? It took me 9 months to start the program. Why? Well, they said, well, we need to have insurance. What kind of insurance? So we need to have flight insurance. Well, that doesn't exist. How can you actually have insurance for this? That was one thing. Well, we're hiring a third party to do the flight. We are a general contractor. So the contract we give is this thick. It owns you, your family, everything else, right? We own everything you have. So you can't really give that to a startup and say, hey, here's my contract, do this. Then the best part, IT. Well, how is the data securely going to go from the drone to us, and how we manage that? 4 weeks discussions later, this was the solution. This is almost 13 years ago. The solution was they'll fly the drone, they'll take the memory stick, put it in a FedEx, ship it to an office, they'll upload to our servers. This is not cloud-based, by the way, upload to our servers. That took 4 weeks, right? So this is just giving you a great example of how hard it is sometimes to actually do these things. That was the intention. So three of us were having that conversation. Actually, Deveron is in this room with us, so one of the co-founders of the lab. And we decided we need to create a safe place. And we wanted to test it. So what we did is we actually initially built a location in Chicago. I'm going to show an image of it. You're going to see what it looks like. Let me describe the location to you. The first 2 years, it was a double-wide trailer, a steel fence, and a steel structure. That's it. Some people even said, well, this doesn't look like a lab or an innovation lab. They are used to these fancy office spaces, all this stuff. I said, well, that's what, actually some people even complain our chairs were uncomfortable. They said, well, these chairs are uncomfortable. Well, that's what happens in a job site. This is exactly the environment that you're in. We also didn't stretch ourselves. We picked 6 key use cases, like from progress monitoring to some safety, some visualization. And what we have done is we built an ecosystem around it, because as Oracle, we couldn't do some of the things which require hardware and software. And then we start working with our customers, directly people from the industry. How can we solve this problem? We would try things. Like we would, let me give you one example. We would pour concrete, put sensors in it. We will see which ones work the best, then figure out how the data would go to our products. We will make these commercially available. So at the end of the whole cycle, what it does is it's actually making it available for the industry. Our first 2 years, we had over 2,000 engagements. And it was actually very surprising to us. We built this small site. We had experts, companies come from Australia, New Zealand, China, Europe, Middle East, South America. We were like, wait, what is going on? The numbers, these are very, very large companies. They would come and spend 2-3 days with us, look at these use cases. We will test them. We will look at what their pain points are. That brought us to the second project. So during those 2 years, a group of us worked on building a physical lab. So you're going to see that in a second. And after that, we actually built 2 other locations. So we actually have 3 locations, but the flagship one, the biggest one, is in Chicago. What else happened in these 5-6 years? Well, if you look at each location, the top one is construction engineering. But then you're seeing other industries too. We significantly expanded the scope. Why? Because it worked for construction. Construction is asset-intensive industry. Well, it works for communications also. It works for energy and water. It works for manufacturing. It works for food and beverage, hospitality, and public safety. So we are working with 9 different industries within our business and our partners and our customers. Scope significantly expanded. The other questionable thing is, okay, so we build this lab, we're testing these, we're bringing these solutions to the industry. Is this scalable? Here's the latest numbers. So our fiscal year is in June. So if you look at the engagements we had at the lab, we had over 5,000 engagements last 12 months. It is scalable. And we are pretty busy. And when I say engagement, it could be actually some of you in this room will be there on Thursday, Friday. So like them coming and sitting down, looking at the use cases, some of them actually seeing the work we're already doing. And I'm going to show you some prototypes, so you get a little glimpse of that. Some of them is actually bringing other their pain points. And one of the key things we do at the lab is this is not a solution center. If you guys know what that means, it is not providing a solution for one customer at a time. It's basically looking at industry-wide problems. It's looking at where our technology, where other technologies will fit in. It maps the people, process, and technology, and then actually looks to see how we could solve it. And concept is working really well. So look, we have 80+ partners. That is very, very important part of this journey, by the way. We could never be able to do this without partners. Chicago, this is what the location looks like. Some of you in this room have been there. And we would welcome you. Please come and engage with us. The trailer is still there, by the way. As you see, the double wide trailer, that's our garage. We're going to keep it. We're not removing that. We have some other plans for it. But the building, we actually built that building during pandemic. So since this is a heavy construction and engineering audience, I got to tell that story also. We started, I want to say, January of 2020, right before March timeline pandemic hit. What we also did is, whatever technologies we developed, we actually use it to build this lab. Let me give you an example. The materials arriving to the site, we had gate readers. We had integration with schedule. So we could do contactless site deliveries. You didn't have to register anything. Now, we were also very practical. We didn't do that for everything. Look, some of you are especially on oil and gas field, when you do shutdown turnaround, some of the things you have to do every little item. We did not do that. this is a building, like we did this stuff that's on the critical path. Steel structure, HVAC equipment, curtain walls, certain things. We did not register ceiling tiles. Let me give you a specific example, right? We had cameras all over. We actually developed during pandemic, social distancing, technology, all that stuff. So what we have built in the first 2 years with partners and us and these technologies, we use it to build this project. We finished in 10 months, on time and on budget. And during that period, it was, I think, around May, I said, well, we should host a webinar and tell the world that all the stuff that you're looking for is actually available. That was also another thing. The first 2 years that we worked, and by the way, it's not just me, it's a large team of people, and some of them are actually in this room also from Oracle. We would engage, and then people will say, well, that's really awesome, but I'm not sure I'm ready for that yet. Well, pandemic fast-tracked that. We've seen that significantly. So during pandemic, some of those things that, especially progress monitoring and reporting, all those technologies that's related to it, really skyrocketed during that period. So we hosted a webinar on April. I remember we had over like 3,000 people joining a live webinar, and typically, you're lucky if you get like 300-400 people live, by the way. I was like, wow, we must be up to something, because we were telling the world there's a construction site in Chicago has pretty much everything you're looking for. From remote site monitoring to contactless deliveries to progress, from the cameras to drone capture, data analytics, everything is in one place. This is from the substation completion. I know you guys know what that means. So we actually had that steel bay moved inside the building. Later, we decided that wasn't enough. We actually moved one of those steel bays. And the next one is a video from the opening. You're going to see that there's actually a factory floor built inside. Manufacturing. So in this location in Chicago, we have construction engineering, manufacturing, public safety, communications, and energy and water. So energy utilities is in one place. We're testing and validating and physically doing things. And at the opening of the lab, which is now a little over 2 years ago, we had, I think it was around 25 use cases that we showcased to the people who came to the opening, say, here's the things we're working on, or some of them are actually completed. They're commercially available. We did the math. If somebody actually had to learn all those 25 of them, they had to spend 3 full days. That's never going to happen, right? So that's another thing. During this conference, if you see someone with an Oracle logo, if you want to go and engage, talk to them. And whatever happens at the lab is we show you what you want to see, not what we want to show. So it's custom designed for you, and the engagement is designed based on that. That's another success, by the way. This is not like a museum that you would go and walk. It's really solving problems and actually engaging with you in a different level. Now, enough about the lab. That's the first 10 minutes. Actually, I'm right on time. So what I'm going to really talk next is what did we do in these years? Here's a use case. You're seeing, hopefully, here we go. A little choppy. You're seeing a drone flying, and it's on a 5G network. It is going to a location. It's going to take an image. That image is recognized with our vision services. It counts the pipes. Then it registers to one of our ERP systems. Why did we do this? This is actually 4 years old. It was, I believe, the second or the third largest steel manufacturer in the US said, well, when I do inventory days, people get sick. No one shows up. Everyone hates inventory. Can we automate this process? I'm sure you're used to that too. So we started with this use case, how we can automate it, right? How we can have a fully autonomous drone fly. In this example, you're seeing Skydio, our partner, their drone. That started 4 years ago. A year and a half later, we switched from that industry to energy and water. Well, I'm going to play a prototype here where drone takes off, flies. It does rust detection. Again, if you look at the workflow, it's the same. It's just a different use case. Now, and some of them in this room, we're working on specific to construction use cases, like You're going to see it actually tonight, I believe. The tower is here. There's a steel tower we built. It has damage and other things on it. The bolts aren't fully aligned. Installation is incorrect. There are many problems with that. We're working on how we can use vision to recognize those things. Visual inspections, right? Automating it, making that process. But if you follow the story, it started 4 years ago. I've told you 4-year timeline, 2-year timeline, and a 1-year timeline, right? So that's another thing we are learning. Creating a space like this, having multiple industries in one place, is also having us learn from other industries too. That's also another fascinating thing happened. Not just breaking the silos within our organization, we're also end up breaking the silos within industries too. Let's see. Now, here is a snapshot of some of the partners. I probably will say this multiple times during this presentation. We cannot do this alone. This is a group of, we have almost 82, I think, right now, partners, a small group of them. And if you know them, there is, let's say, as big companies as Verizon. So like Verizon provides our 5G, millimeter wave, private and public 5G, to a smaller firm with 60 employees. So they are various sizes and shapes, and we work closely with them to figure out how to actually solve these problems. This is just a snapshot of that. Now, let's get to the meat of this presentation. 15 minutes in. All right, what's happening in robotics and AI? If I were to describe, let's start with AI. Well, artificial intelligence is not new, right? It's been out there decades and decades. And the one that everybody is really excited about is Gen AI, and I'm going to talk about that in a second. But if I were to categorize this, I want to start with machine learning first, right? Machine learning, you have tons of data. You can train them. It can look at the patterns, and it can do tons of things. And we have products that actually do that. We have stuff that actually will tell there's 80% probability your project is going to delay by 10 days, and here's the reason why. That's purely based on machine learning. Then I would say computer vision. Vision has significantly improved, right? Looking at things, recognizing things. Now we're taking it to the next level, looking at things, recognizing things, looking at anomalies, and actually being more proactive, rather than just saying, here's the things that are here, or there are 18 pipes that are laying down. And the next one is Gen AI. I will give you specific examples of those prototypes. But let's start with robotics. This is, again, 4 years ago. At the time, we were working with Faro Technologies, which has scanning technology. Some of you might know Faro. And this is our construction site. So this is one of the first locations, actually, Faro integrated with the Spot. Now, later part of this presentation, I'm going to show you a study we did a year ago, which actually will look at cost-time analysis. I'm going to walk through all this in a second. So we're not only just integrating things, we're also looking at what are the benefits, which use cases make sense, what you should be using it for. So this is 2020. Actually, today, some of my colleagues were showing, we're having a data center-focused event at the lab today. And today, it's a different partner, Anybotics, which is based in Switzerland. If you know them, I believe some of the oil companies, oil and gas companies work with them. They're actually at the lab. We built a mock data center, by the way, testing it how these robots walk around the aisles. Now, let's talk about Gen AI. Let's hit that. There are 5 prototypes that I'm going to show. First one is this. We showcased this. So let me give you a timeline. We first time showcased this in September last year. This September, audiences are going to get an update at the Oracle Cloud World. By the way, please join us at the Cloud World if you can. We have a construction track there, too. What does this do? This is during RFP process. First thing you do is you have an RFP. You upload it to a bot. A bot reads through the details, and it automatically generates a baseline RFP schedule for you. Now, this is not going to replace schedulers. Number one, see the summarization is just showing up. And then the bot keeps asking some questions, like it's going to ask what type of steel structure this the person says in a second. It's steel structure, it's this and that. So it provides some information. And we all know RFP documents are not consistent, yes? And they do not contain all the information necessary to actually build a baseline schedule. Some of the stuff, you actually have to look at the drawings and identify them. But you provide these information, and it generates a baseline schedule. We have been working really closely with a good number of schedulers on this. And what they have told us is typically what they are used to doing is if they have a similar project, they will go to a P6 schedule, look at that project, change the timelines, look at the baseline, make some adjustment. But that's a lot of labor, right? By doing this, something would take them, I want to say 3-4 hours. We're reducing it to 3 to 5 minutes. That's the experience. Now, they are still going to work with the schedule. They're still going to take it, modify it, adjust it, whatever they need to do. But it's saving them time into day-to-day operations. Now, one of the key things we always get is from the audience. They want to, from our customers, they want to respond to RFPs fast, but they also want to do it reliably, and they also want to win it, right? So this is, again, designed to help that process. Why we pick RFP? In some ways, kind of a low-hanging fruit, if you think about it, right? It is kind of a starting point in terms of how you would build schedules. And when I was in operations and I had to put an RFP together, I had to chase the schedulers for a week before I could get their attention to actually put the schedule for me. So I'm very familiar with the process itself. And before I move to the next prototype, I want to say this. This is not replacing schedulers. It's just giving them a tool to actually create a baseline and help them fast-track the process. Next couple prototypes are for utilities, for energy. This one is, we showcased this, we actually completed this work in March. It's a prototype, and here we're asking the bot, I'll read it to all of you, summarize the service history of this transformer, right? Look, if you played with any Gen AI technology bots, you'll know that it does a very, very good job summarization, right? It can go look at the data. There's a technique called RAG where you can even direct it to certain locations, and it does a really good job of summarization. So it does that. What is different in this one? The next question. We ask and say, how many customers does this transformer serve? Are any of these customers identified as critical? Think about that for a second. If you want to answer that, how long time it will take you? Pretty significant amount of time. Because you have to look, data is all over the place, right? How many customers it serves, you need to look at probably a different location for that. The identifying which customers are critical, there's another challenge by itself. So we are trying to automate this so it can go and look at this information and provide that. I also want to address something really important for Gen AI. I'm sure you heard this word hallucinations, right? How these things work is it's looking at the data, it's statistically picking up the best next word for it, and once it hallucinates, it's not good, right? So that's not what we want. Oracle's approach has been different. What we are doing is we are actually looking at specific use cases and then designing it so it will answer that very, very accurately. So this is not like free for all. You're not going to ask it to write you a poem, right? What we're doing is, let's say you, and I'm going to show that prototype in a second. Let's say you have a lot of mail and you wanted to summarize that. So the best way to do that, what we have learned throughout the years, is you will have a summary mail button, which is using Gen AI, but we prompt engineered that. We tested thousands of times. And then we even trained the specific model behind that button with that data set. That then allows you to get very, very accurate response. That's what's going on. Because, again, technology is awesome. But for our field, we want, 99.9 reliability. We don't really want it to say things which are not accurate. And that's how we're solving it. The next one I'm going to play, hopefully sound turns on, is a hands-free AI agent. I'm going to explain the difference between this and what you probably have seen something similar to this last decade. Many examples of this, but I'm going to play it first. And then talk in a second. No?
Overview.
Generating the overview for the work order. Transformer at Merle in court is a Siemens Electric TRS 29. Submit the form.
Start camera. Capture photo. Submit form.
Form submitted success.
All right, very short video. So what's the difference between this and any other hands-free thing you have seen? It's using LLMs, large language models, to summarize things and verbally tell you what you're seeing is what it is, right? Think about that. You're looking at an object. It can recognize what that object is, and then specific things that you're looking for that object, it can go and find it and bring it to you. And then at the end of it, what we're doing in this prototype is actually the person is finishing the order without touching anything. Everything is done in voice. We actually have a group of customers. We're going to field test this. We are looking at major things. I'm sure some of you are already thinking about this. What about the noise, right? There's a lot of noise. What about accents? What about field conditions that affect the voice that you say this? So we are actually going into the next phase. If any of you are interested in the energy space, please talk to me. We are moving to the next phase where we would then field test it with actual customers in the energy space. The next one, and you can see this live if you come to the lab, which is we fully autonomously have the drone fly and come to these steel. As an example, we have the steel structure. By the way, that image that you see looks like rust. Is not rust, just to be clear. It's decal. It's just an image. We're not going to put that rusty steel structure in the lab. But we're kind of tricking AI, right? And it does recognize it. In this example, Oracle's Vision Services says, well, it is 90% probability this is rust. And then what it does is it registers to a work order management system that is used by utilities. Again, the same team, right? How can we automate this? How can we bring in artificial intelligence? And I've been giving different examples so far, right? I've given the Gen AI ones with large language models. I've given some examples with machine learning. This is vision and recognition, right? So those are the things that we really focus on. The next one is taking the chatbots to the next level. This actually, a group of us worked on this recently. Let me play this for a second. Let's see. All right. So it's talking to a project manager. It's called Project AI Assist. And the question is, what task do I need to do? And what it's doing is it's looking at summary of all the mail. It's prioritizing them. And then it is actually recommending actions. How does that do it? It's using, yes, large language models, but it's also using a technique called AI agents. And I'm going to go deeper into that in a second. So what task do I need to do is probably one question I ask myself 17 years being in the industry every morning that I woke up, right? What is going on my side? What do I need to do today? And what risk do I need to manage? It's actually that simple. That's what we do every day in and out. So if we can find a way to perfect that and provide you the information that you need that you didn't even think of. Actually, Paul and I were having breakfast. We talked about this. Like, he was saying to me, his team does analytics and, pick stuff up and then show them. This could potentially show things that the team or the humans weren't able to recognize. Like, there are certain patterns and things that we were not able to catch. So everything I have shown you so far is either a prototype or a technology we're developing. But we do also have commercially available technology. So the stuff that's on the screen, which is starting from scheduling, which tells you what's the probability of delay and likelihood and gives you the reason. By the way, reinforced learning built into it. If you do not agree with it, the model adjusts itself. That's a very complicated thing to do. We have the workflow engine, which looks at the problems potentially. We have an engine actually reads through the mail and picks up, everyone's going to love this word, litigation. So it picks up things that typically might turn into litigation one day, so it's actually picking them up and flagging it. Look, running a project. How many times these small issues never made it to management? Many times, right? They're sometimes resolved. But sometimes, my personal experience, it's never one issue, by the way. It's multiple things kind of pile on top of each other. That becomes a big thing, and then it explodes. Running projects. So it is looking for those patterns. And the one to the right is about safety. So it's the new matrix technology that we have. It actually recognizes images, recognizes, and automatically does safety reporting for you. So everything that you see on the screen is commercially available. Also, one Oracle for construction engineering. What does that mean? Well, we have these applications, right? Most of you are very familiar with, from Primavera to Unifier for scheduling, ACON architecture, payments, processing, scheduling, all that stuff. But then you have your Oracle applications for back of house. This is how everything ties together. Now, how does this relate to CII? We have been working very closely with the teams who work on advanced work packaging. And I believe later today in the afternoon, you'll actually have a session to talk about the data in advanced work packaging. We even custom configured some of our solutions to enable that. And that's what we are contributing to the organization, to be able to provide the technology, because eventually, it's all about data and governance. I'm sure everyone in this room will agree to that. And all these technologies I have shown you, yes, they're awesome. It will predict things. It will do all these things. But if you don't have your data, and if you don't have good governance, you're probably not going to get the outputs that you want. So it's very important to follow these principles and have a good baseline. So then, when it's time and when you're ready, so I want to say that too, when you're ready to actually deploy some of these technologies, your work is much, much easier. You do not need to do much of that. Now, technology also significantly improved. In the past, I would say 5 years ago, used to say that you need to go back and clean up your data, you need to do all this. Yes, it did improve. It can work with unstructured data. It can do a lot of things it wasn't able to do, but the reality is, if some of the underlying data is not accurate, the results was not going to be accurate. We all know that. Now, I've got 30 minutes left. Let's talk about something that you can leave this room, something very tangible. Yes, I talked about the use cases, talked about the lab, talked about the things we're working on. A year ago, we published this report. It is 22 pages. So anyone who sees CII is not going to be surprised. You can publish a 22-page report, right? What we have done is we wanted to see reality mapping. Look, we do not provide that hardware. When I say reality mapping, it's LiDAR or photogrammetry, right? We do not have them. We don't make them as Oracle. But we have partnerships with a lot of these companies. And we picked one for each use case, and we tested it. Let me walk you through the process. This is the lab. You've seen the image. Here are the technologies. I'm going to stop for a second so you can look at it. LiDAR is on the left, reality mapping on the right. Stationary LiDAR, we actually did this with 2 of our customers, Clayco and Pepper Construction. They're vertical builders. They build data centers, buildings, warehouses, all sorts of projects. So what we have done is we had them provide a human coming and scanning that big open area that you've seen. That's 10,000 square feet. And then we had a mobile LiDAR. Someone, where's this LiDAR, walks around. We had a structured light, which is typically used for real estate. We had a LiDAR-mounted robot, which is the example you've seen, the robot carries it. We had a manual drone. We have a fully autonomous drone. We had someone walk with a 360 camera, and we had a smartphone. By the way, it took us 1 day, right? No surprise. I also have to admit this. We totally underestimate what's going to take to do the cost and time study. So we said, well, we do this in 1 day. In 3 months, we'll be ready. It took us 6 months. Okay, so appreciation to the CII, all the work that you do. I quickly learned that, pulling this off, really figuring out what it's going to take. Now, what did we do with these? At the end of the day, it's all about use cases. You all know this because that's what you do every single day. We come up with these use cases from as-built documentation to surveying, doing installations, survey-grade QA/QC, scan to BIM. These are the use cases. So later in this presentation, you're going to see the technologies and how they map against these use cases. Here's our setup. We captured the data. It took us 1 day. And this is the workflow from the left. The reality capture and the models. The data goes into our smart construction platform. And then we actually visualized it and put everything in one place with a partner's product named Reconstruct. What did we learn from this? Before I get into the learnings, I want to also show you this. We also looked at the visual outputs. Look, it's one thing to measure time and cost. Yes, that's great. But also visually, how does this look? Like a LiDAR output from one technology is actually very different than the other. And as you have maybe recognized this, we haven't named any company names or that. We just pick one from each one because it's not really our job to say, well, this, LiDAR scanner is better than this other one. We just pick one. So here's some reality mapping outputs. And this is probably the most exciting part of that study, time study. Let's talk about time, how long it took. Since CII is, I'll say, partly academic and partly industry, I think you will relate to this table. Sometimes, it is hard for people to understand, but I think this might be easy for you. The timeline on the left, that vertical one, is how long it takes to capture the data. And the bottom timeline is capturing the data to coming out with a meaningful outcome. So let me walk you through some specific examples. And the technologies are in the color. The first gray box is if you do it once. The color box is, the color not box, circle is if you do it multiple times. Let me give you one example I think that's going to clarify understanding this. If you look to the right, if you look, human using a tripod scanning takes the longest time in all these technologies. And you know how it takes, right? You need to set it up, you need to get control points, all this stuff, right? But if a human comes and does the same location again, yes, they improve over time. So there's some improvement. You see that circle actually comes down a little bit, new color. Well, when you attach to a robot, the improvement over time is significant. You see that drop? Significantly drops. Why? Because all you're doing is you pre-program it, you do the scan once, the next day you press a button, it does the scan for you. The next thing I want to show is what happened with the drones. If you look at the drones, if you look, makes sense, setup time for fully autonomous drone capture was longer. Makes sense, right? You have to go, you as a human have to set this up. Compared to human flying a drone. But if you look at the improvement, human drone flight improved a much more, I'll say, much more than any other technology. Why? Any of you who use drones in this room will attest to my next statements. Even a manually controlled drone has a lot of autonomy built into it today. You're not really actually flying it. You can set the flight path. It will do a lot of the things for you. There's a lot of autonomy already built in the manual drones. So because of that autonomy built in, the time saving was, again, more than other technologies, but it wasn't as significant as doing it with a fully autonomous drone. Because what you're doing is, like the Skydio drone that we have, you can program it, have it fly, you can say, go to that corner, this corner, this corner. It will do the flight. It will capture the data, lands itself. It will save the data to cloud, and we capture that data out from the cloud. I can say, 11:05, every day, do this flight. And it was just going to do it. That's it. In terms of that technology, we're actually seeing, because we work with two industries really picking up autonomy. It is public safety, autonomous flights. We actually have a drone box. The drone comes out from a box and flies. There's a lot of public safety use cases. They're putting them on top of the roofs. Also, utility companies. There are a good number of utility companies are actually using it for inspecting their assets and putting these boxes. The drone comes off, flies, does inspection. And when you ask them, because we engage frequently, what are they using it for? Yes, they're using for operation, but they're also using for security. That issue during pandemic has, yes, slowed down a little bit, but still out there, according to my discussions with them, in terms of protecting your assets and all that stuff still continues. So the places that they need to have this, they said it's really helped a lot. And many conversations I had, they were saying, well, you put cameras all over, but they figure out the direction the camera isn't looking at, and they still figure out how to enter it in, right? But this is really eliminating it, put sensors around it, the drone takes off itself. It sounds like a sci-fi movie, but it actually is happening today. Now, the other technologies, improvements hasn't been that significant. That's the output. Again, I'm giving a high-level summary. At the end of the presentation, you will be able to, either from a QR code or connect with me, we'll be able to provide this report to you. Now, time is money, right? Let's talk about cost, what it takes. In terms of cost, no surprise. If you take a robot and attach a laser scanner, that's $50,000. The robot is over $100,000. It's the most expensive thing, right? It's on the top right corner. And the second most expensive thing is just the laser scanner itself with the human, right? Human labor is expensive also, so you got to add that up, and a skilled person to actually do that. And now the thing we have learned through this experiment is if we get 5 surveyors into the same spot, they're going to scan it differently. Again, there's a human skill level, there is practices level, how they do it differently. It's been, quite a learning experience for us. The same thing. Actually, autonomous drone and a manual drone cost is kind of comparable. But improvement cost over time significantly because it's just repeating itself. Let me give how that works. If I go to a job site and I fly a drone, and I need to do that next week, if you have in the second use case, you do not need to go there anymore. You don't need to drive for 2 hours to go to a job site. It live streams, you press a button, or you schedule it, it flies itself. In terms of manual drone itself, by the way, our industry is in the top. I don't know if you have seen studies, especially last 5 years. If you look at which industries use drones for data capture, construction engineering and real estate are in the top when you look at those. And in terms of cost, again, this shows a little bit of difference between what the costs are and what it takes to actually put these in place. Now, I'm going to spend a little bit more time on this one. The technologies are on the left, and the use cases are listed 1 through 9. Green means it is actually solving the problem today. Light green means it's emerging technology. Let me give you specific examples again to make this clear. If you look at stationary LiDAR, and remember, it was the most expensive one, right? Actually, no. It was the second most expensive after you put the robot, right? I mean, the time and cost. But in terms of time, it is the most expensive because human has to still do it every time, versus if you put a robot, time improves over. If you look at this, you can put a stationary LiDAR, send a surveyor, and survey every single day. Well, it's expensive to do that. It checks all the boxes, but in reality, are there other technologies much cheaper for you to do that? Yes. What you see here is the box number 1 is as-built documentation. Manual drone flights checks the boxes. So this is giving you an idea that if you really want accuracy, you have to go with stationary LiDAR, LiDAR-mounted robot, or mobile LiDAR. And as you're going through this table, it makes it very clear that you can't just look at the use cases. When you're making choices, you need to look at the use case, you need to look at the technology, this table, then you also look at the cost and time study to see what makes sense for that at the time. And every job site is set up differently, right? I know, there are pilots on many of the job sites already, so you don't need to travel. I mean, look, you need to consider all these things. What's really important from this is, and this came out as there are 6 things we learned from the study. At the end, I'll walk you through. The promise of 360 video and smartphone. Oh, sorry about that. 360 video and smartphone. Because, and this is AI also, there are new techniques, especially in last, I want to say, 2 years, improving how we capture data and process it. Gaussian splatting is one of them. There are others that are out there where you can take multiple images and actually will create a full 3D environment for you. And this falls under the umbrella of, I would say, AI. Because those things are improving, also 360, I'll say a smartphone video, literally like there's technology now, you can take a smartphone, or it doesn't have to be a smartphone, but for the camera reasons, take a phone, walk around, and you do not need to walk slow, by the way. You can walk around, and it looks at that image, it breaks all these frames into 30 frames per second, it breaks them, and it uses that data to create a 3D point cloud. Again, this is not science fiction, it's existing today. Now, if you look at this, what we're seeing is, well, if you look at all the way at the top, the stationary LiDAR is expensive tool itself if you were to do the first use case. But we're seeing that these photogrammetry techniques are improving so much, AI is coming into them to actually process this the best way. As they're improving in the next couple of years, that's my bet, you're going to see more photogrammetry coming into our lives to capture reality than anything else. Look, LiDAR scanning is not going anywhere. Accuracy, you need millimeter accuracy, you're going to need that. Example from the lab. When we scan all this, we learned that the handrail from first floor to second floor is 1 millimeter off. This is a lab. Does it matter? No. It didn't matter to us. But if you're doing, I don't know, oil and gas facility, you're doing certain things that require extreme accuracy, that 1 millimeter matters, right? So again, it goes back to your use case, how you capture, and how you pull it together. Well, this was published last year. What you're watching it is from March this year. If you're interested also, you can participate in this. Once a year, we decided we're hosting a drone skills competition with the pilots. So human pilots compete against each other. We actually put a course based on NIST standard, Nation Institute Standards. We custom modify it. There are buckets everywhere. There are QR codes, other things. They capture, and we actually have a group of judges compare, and then, I think it's a fun exercise. By doing that, we are also learning all the techniques and styles of each pilot, how they capture the data. It not only, I'll say, an interesting day for us, but also helps us to figure out what are the techniques and how they're changing. The same day, we also did full autonomy versus human capture too. One of the things we have learned, no surprise, is the fastest human captured the data of that course was 3 minutes and 30 seconds. Drone, fully autonomy, was 2 minutes and 30 seconds. Now, does that really matter? Most likely not, right, today. But at some point, it's going to matter. Because the difference isn't that significant. In terms of if you're running a job site, you're doing this. Now, when a pilot flies, if you are, like, I'm running the job site, I don't care if they take 3.5 minutes or 2.5 minutes. I'm going to tell them the quality is the most important thing, right? Capturing the data. And the quality of that drone capture is getting very close to what human can do. Now, I don't think it was really comparable because we also had the human pilots bring their own drones, right? Oh my God, if you're looking for an industry that, from one model to another, the quality, what they can do, what pilot skills are, there are so many factors. So it's not really apples to apples comparison. These are the results. The key one, I want to say, the promise of autonomy was significant. And since we are at CII, I think one of my favorites is the last one, planning for reality capture and completion of reality mapping. Planning is super important. I'll give you another specific example. So if you put a stationary LiDAR here and scan this room, what does it do? It captures pretty much everything. It captures ceilings everywhere you can, right? Because the rays will bounce off, so it captures it. Well, if you're using a 360 video and you wanted to do it for a certain purpose and you walk this, did you really look up with the 360 video? Maybe not. 3 months from now, if you want to look at what certain conditions were on that ceiling, you are not going to be able to capture that. It, again, goes back to planning, planning, planning. You might consider, oh, reality capture is just a tool, it's capturing the data. No, it goes back to the principles like anything, like scheduling. You still need to plan it. You still need to know what use cases you're after, and you need to go back and look which ones make sense. All right, I'm in the last 10 minutes, robotics. I might not have time for questions, but what I will do is you might have 5 minutes. If we do, I'll be happy to talk to you guys after the session. What's happening in the robotics? Look, robots aren't new, right? They're heavy in manufacturing. They're everywhere. People are using it. There's, again, a huge hype about humanoid robots. Have they improved significantly in the last 2 years? Absolutely. Are they ready for our construction sites? Not really. What you're seeing today is humanoid robots are improving drastically. Literally every month, you're seeing new developments. But they are still, the promise of them, or I want to say the actual use cases that we're seeing is actually in car manufacturing. So if you follow the news last 6 months, you're going to see from BMW to Mercedes, like actually BMW factory in North Carolina, to Mercedes, to Ford, to others, Hyundai, they're all testing these robots at their factories. Now, aren't they used to the robots? Absolutely. What do they have? They have fixed robots with the arms, and they do operation. They're reliable, right? They're in a cage. Then there's this other factor coming in, human and robot without the cage, right? So you're actually like free flowing. So there's safety things that are considered. But currently, the use cases that are really picking up is when a car is coming down the line, it actually can do inspections. The robot can go and look inside and capture something that typically a human might need to do, or you need to fully custom program a robotic arm to go and look at that side of the vehicle. Or bringing parts to some worker that's actually on the site that needs something at that moment. So that's really picking up. Why is this happening in the automotive industry? I think my theories are, A, that industry is very used to robotics. Yes, they're used to working with it. They're used to the protocols and the safety and everything else. B, their environments are still super controlled, right? It's a very controlled environment. It's not changing every hour. It's not changing every half a day. So they are still doing that. But it is going to change. I want to say next 5 to 10 years. I don't think it's next year, by the way. In next 5 to 10 years, we are going to see these robots actually working on our job sites. Today, the use cases that I have shown you is been mostly about capturing data, right? Whether it's a flying robot, which is like a drone, right? Or it's a ground robot, which is like four-legged or whatever, rover, whatever it is, it can be around your job site to actually capture data. But it is coming. It is changing. Now, why is it changing this drastically? Because we either pre-program robots. By the way, those arms that actually do the work is fully pre-programmed. They simulate it. They have simulators, simulate the actual work conditions, how the vehicles are coming, where it needs to weld or other things. They simulate it. They train it. They train it millions of data points, and they control it. It does a pretty amazing job. Or train it with machine learning. So that is what is really changing how we deal with robots. This robot and the Skydio drone, I'll tell you how it's actually trained with machine learning. So I'm going to give specific from the drone example. The way you would train is, it's actually going to give away my age. It's like a VHS player. I'm sure you know I hope most of you know what that is. Depends on the crowd. It's like a VHS player. You hit record button, and you manually fly it. You could fly it. It will go to those corners. Let's say I did this flight, and when I come to landing, I click a button, say it lands itself. Let's say I manually did this flight, and my flight time was 5 minutes. This is how machine learning and AI works. that flight pattern, it saves itself to the cloud. The model optimizes that flight pattern and downloads it back into the drone. So when I do the mission, my 5-minute flight will be 2 minutes and 30 seconds because it optimized everything. One of the things it was hard to see on that video, which is very interesting, when we compared autonomy versus humans, let's say the drone fly, the humans would come to this location, and then they will look down to see this paper that's here. Well, when you optimize it with the AI, the drone is flying, it's adjusting its camera as it's going over the paper. And it spends like less than half a second that it moves to the next location. Yes, it sounds like Terminator. Yes, it is. But it is actually working, right? That's the difference. How we train these things have significantly improved with the introduction of ability to record human actions, and it's called like human mimicking, right? A lot of video feed, by the way, autonomous vehicles, you're seeing that too now. They used to do a lot of pre-programming, like I want to say 4 or 5 versions ago, Tesla said, I stopped pre-programming. I just trained my autonomy is fully with video, all the video that I captured. And the users now tell that it is actually driving more human-like because it's learned from the human video recordings, right? That's a huge difference. So this is currently available. It is used where it's autonomy or not. What is really changing is the next one. AI agents. I know it is a kind of weird name, agent. It is not a new concept, by the way. What you do is you set a goal. It creates tasks for you. It can even write a code and execute it. This is like that thin line between, the term AGI, like you're setting a goal and it does it. And like one of those I played with a year ago, I used and I said, hey, build me a project management plan for a 2-story, 50-car garage with sustainable materials. It did a fairly good job in the first 3-4 minutes and then didn't, right? This is prototype. But initially, it started doing stuff like, it said, I need to check the zoning, tell me the address for this location. It actually started building a project management plan. Today, project managers in this room, isn't that what you do every day? When you handle a new project, you already have experience of decades of experience. You kind of build that in your head, that these are the things I need to do. That's what agent does. Now, the difference is agent will be able to build those and then even write a code for you so it can go and execute. That is, again, that is the humanoid robots is one part. By the way, humanoid robots, improvement of that also ties to this. You do not need to train those robots. When this thing truly works, you do not need to tie them to any pre-programming. Because if it has been trained on certain tasks, it will actually improvise and do the other things. That's what's coming. What does this mean for project management? Imagine I set the goal, it set the task, it can order materials for me. Machine-to-machine ordering is massive, by the way. It's a massive industry outside of construction. But other industries, the ordering stuff is insane. They're already happening. Your vending machine already communicates and orders stuff, and then the people deliver it without you actually knowing it. This is already happening in the last 10 years, right? So it's not new. The same thing with physical execution. Imagine these technologies kind of tied together. Large language models, machine learning, computer vision, introduction of how you train all this with robots, tie everything with flying robots and ground robots, and eventually you'll be able to just set the goal, it will execute itself. Yes, today it does sound like science fiction, but we are seeing parts and pieces coming together. And I'm also a big believer of not one technology is going to solve this. It's multiple things actually coming together. I got 1 minute. I'm right on time. Now, if you would like to download that report, here's the QR code on the screen. You can take an image and download it. You can also connect with me on LinkedIn and send me a note. I will be able to give you, I'll send you the link back so you'll be able to download that. I want to end it with this, 35 seconds. I hope you got a good sense of what's happening today and what's coming. I do not believe any of this is going to replace us, first of all. I hope not in my lifetime. I don't believe in that. Because human creativity and ability to do things are extremely valuable. There are a lot of things we would love to automate, so we actually take those off our plate. I know sometimes when people say that, it sounds like it's a sales pitch. I wish, by the way, that example I've shown you, I wish I had a tool every morning when I walk to the job site. It kind of guide me through what I need to do that day and made me some recommendations. Wouldn't that be wonderful? You actually have something kind of alerting you and say, hey, have you checked about this? Have you checked about that? Now, can that be a little bit of like an overbearing parent? Maybe. We'll deal with that when the time comes, or because AI is here to serve us, not the other way around. But I truly believe when these technologies are merging together, they're really going to have a big impact in the next couple of years. And thank you.